Welcome to this explainer. Today, we're going on an absolute mind-bending journey. We're going to start with incredibly simple shapes, stuff you probably doodled in grade school math class, and follow their logic all the way up to, literally, the creation of the universe. The title, "The Boundary of a Boundary is Zero," might sound like some cryptic riddle right now, but I promise you, by the end of our time together, you're going to see it as a profound key to understanding reality itself. It all really begins with this ultimate cosmological question. How does the universe create everything out of absolutely nothing? It's the ultimate puzzle, right? Philosophers, physicists, they've agonized over this for centuries. How do you get matter, energy, and physical laws from a total void? Well, we're going to explore how the answer actually lies in a seemingly trivial, yet perfectly elegant geometric rule. Okay, let's dive into this with our first section, the zero boundary rule. So the formal definition we're working with today is simply that the boundary of a boundary is zero. This is a principle taken straight from algebraic topology. It basically states that closed structures embody a sort of self-cancellative symmetry. Now I know exactly what you're thinking. Algebraic topology? Self-cancellative symmetry? It sounds like incredibly dense academic jargon. But stick with me here, because this concept is actually highly visual, super intuitive, and frankly, it's pretty beautiful once you see the mechanics in action.
Let's start small to build up some confidence in the math with Section 2, Loops, Lines, and Disks.
Let's look at a basic, straight, one-dimensional line. A 1D line has zero-dimensional endpoints, right? It's just two dots on either side separating that line from the empty space around it. Now, think of this directed line kind of like a financial transaction. Any movement implies a starting point and a destination. There's a fundamental directionality to it. The initial starting point represents the debt required to start the line. Let's mathematically assign that a value of -1. The terminal point at the other end, that represents the payoff for actually completing the line. We'll give that a value of +1. It's just a basic algebraic assignment where moving away from the start is negative and arriving at your destination is positive. A simple transaction from negative to positive.
Now I want you to visualize taking that straight line and physically bending it. Just imagine grabbing those two endpoints and curving the line around until it forms a closed loop, perfectly bounding a flat 2D disk right in the middle. The line itself is now the boundary of that disk.
So what exactly happens to our endpoints? Well, because the line is now a closed loop, the starting point and the ending point physically touch. They merge into one. And because our starting point was a -1 and our ending point was a +1, when they merge, they completely cancel each other out. They literally equal zero. They no longer separate the line from the space around it. So we've just proven our rule visually. The zero-dimensional boundary of the one-dimensional boundary of the two-dimensional disk is exactly zero. It's a tactile, absolute, perfect cancellation.
All right, let's scale this up. Moving on to Section 3, folding the tetrahedron. Imagine a flat triangle drawn on a piece of paper. Step 1, we decompose or divide that triangle into 4 smaller adjoining triangles. Step 2, we draw arrows to give them all a uniform clockwise orientation. You might wonder, why clockwise? Well, in topology, consistency is absolutely key. By assigning the exact same directional flow to every single area, we create a strict mathematical standard to measure how they interact. Now look closely at the interior edges where these smaller triangles touch. Because they're all swirling clockwise, at any given shared boundary, the arrow of one triangle is heading up, while the adjacent triangle's arrow is heading straight down. They point in exactly opposite directions. So those inner boundaries immediately cancel each other out. Step 3, we physically fold the outer edges of our big triangle up, transforming it into a 3D pyramid shape, which we call a tetrahedron.
Now, think deeply about the resulting geometry of the 3D tetrahedron we just folded. Its two-dimensional flat faces form a closed boundary that permanently traps a 3D interior space. And those faces are themselves bounded by one-dimensional edges. But here is where the magic really happens. In flat 2D space, those outer edges were completely separate. But because we folded this shape together into 3 dimensions, every single one of those outer edges is now structurally shared by 2 adjoining faces. 2 faces are essentially fighting for the very same 1D edge. And thanks to that consistent clockwise orientation we set up earlier, at every single edge of the pyramid, the directional arrows of those adjoining faces are running in perfectly opposite, head-to-head directions. And boom, there is that highly satisfying number again, 0. The clockwise and counterclockwise orientations cancel out absolutely everywhere along those folded edges. Just like the merged endpoints of our loop earlier, the boundary of the tetrahedron is perfectly zero. It is entirely self-cancellative.
This brings us to a massive shift in our narrative. Section 4, the physics of mom energy.
So the absolutely crucial point here is that this exact mathematical cancellation rule isn't just some neat geometric party trick. It has massive, fundamental applications in the theory of fields in modern physics. It actually describes the mutual grip of matter on space and space on matter. The legendary physicist John Archibald Wheeler coined the term momenergy to describe the ultimate conservation of energy and momentum in our universe. Momenergy essentially tells us that matter and energy dictate exactly how space curves, and in turn, the curvature of space tells matter how to move. It's this endless, perfectly balanced feedback loop. And physicists use this precise boundary of a boundary is zero rule to explain that exact conservation mathematically. The geometry of space itself self-cancels to maintain stability. Furthermore, we can interpret this in terms of pure information. A boundary fundamentally acts as a constraint. If you think about it, a boundary separates interior from exterior. And by doing so, it creates an informational distinction. It separates state from syntax. To put it simply, without boundaries, everything would just be a formless infinite soup. The boundary provides the syntax, the structural rules that allows a specific physical state or object to actually exist within it. It's the mathematical framework that allows things to actually be distinct from other things.
And this brilliantly illustrates our final concept, Section 5, everything from nothing.
John Archibald Wheeler put this idea remarkably well. He noted that the sheer ubiquity of this zero-boundary principle inspires hope that we will someday complete the mathematics of physics and derive everything from nothing, all law from no law. That is a staggering thought. The deepest truths of reality, the very laws of physics that govern our existence, might just emerge naturally from the pure, elegant logic of geometric self-cancellation.
This mathematical concept provides the ultimate justification for ex nihilo creation, the literal creation of the universe out of absolutely nothing. It's the philosophical idea of law without law. By utilizing this simple zero motif, where boundaries merge and perfectly cancel each other out, it mathematically allows an entire universe full of wildly complex structures, dynamic energy, and heavy matter to just exist. How? Because while the individual parts are incredibly complex, the total sum, its ultimate, grandest boundary, remains absolutely zero. Think back to our geometry. Just like the 3D tetrahedron was physically folded into existence out of flat space, our universe is essentially folded out of the void. The universe isn't a violation of nothingness. It's really just a highly structured, geometrically folded version of it.
Which leaves us with this final, truly provocative question to ponder. If the boundary of all boundaries is mathematically zero, are the constraints, the matter, and the rules of our reality just a grand, self-canceling illusion built from absolutely nothing? It fundamentally shifts how you look at the space around you. Everything you experience is held together by this intricate geometric balance, a balance that ultimately amounts to exactly zero. So keep looking closer at the seemingly simple shapes around you, because they just might hold the secrets of the universe.